Good morning, everyone. I'm Milango Tabor, founder of Near. Near is a platform for geospatial as well as the machine learning applications, especially for water, wastewater, stormwater, public works, and other utilities. We have a very nice geospatial platform. You can upload different types of layers, but also I'm very excited to show you how you can run some simulation, especially some SWM model simulation on one of our virtual machines. So virtual machines are very powerful machines. It has a lot of GPU power. Depending on your use case, we have a different sizes based on a different, H100, B200. It has a lot of RAMs. So you can spin up a machine and you can rename it whatever you want to do. So let's do like a test, maybe, yeah, near test VM, and you can um, um, deploy it very fast. So I'm going to deploy this one, and hopefully it takes like a couple minutes because it needs to install PyTorch and Jupyter. Plus also it has the bare metal machine, which means you're owning this machine. You have the whole control of what to install, what not to install. So um, that's the power of this GPU machine. So I'm going to deploy this, and then we can come back to show you guys how to run a SWM model in this VM machine. So let me deploy this. This is gonna uh, spin up, and once it's spin up, we can come back and start installing some of the applications. I do have some machines already I'm running, so I'm just gonna show you guys an example. So once this is deployed, it shows your Jupyter notebook. So it's pretty straightforward. You just click on it and you will open Jupyter notebook. As you can see, there's nothing here. Um, so you have a terminal, but also you can create any new notebook, and also you can upload some of this, files from your computer if you want to. So first example I want to show you guys is from PySWM, which is a swim engine. It's a wrapper for a swim engine in Python. Very powerful um, wrapper. So Brian and his team has done excellent job of creating this PySWM. I'm going to go into examples. There's a bunch of examples here. Let's pick the very smallest example we can actually download this, and I already downloaded this. I'm going to upload this back into the VM machine, but this is a simple data set to show you how to run this model. So this is a compressed file folder. I'm just going to upload this. Okay, it's done. So I just want to unzip. So I'm going to open up the terminal. It's a very simple command. I will do unzip space tab, and let's unzip this folder. We'll see what's inside this folder. It's going to take a minute, and once it's opening up all the files, you can go through what's in there. So it's done opening all these files. It has a nice PDF that shows you some instruction from Brian. You can kind of read through it, but it's pretty straightforward. What I'm going to do is, it also has the .py file. This is the Python file. You can run it using Python through the terminal, but we can run it through the notebook. I will show you really quickly. We'll select the default kernel. I just want to rename this as our first example. And I'm going to open up this file. I'm just going to copy this, whatever in this command line, this code, and I'm going to paste it here. Thank you to Brian and his team for creating this example. So just paste it in this cell, and I just want to run this. So let's run it. So it took only less than a second because it's a very small model, and you can see it's already created this RPD file. And bang, we're here. So it gives you nice results. RPD file. This OUT file is the binary file. You cannot open it, but PySWMM has the reader, so we can, the next exercise, we can actually show you the output of all the nodes and links. So that's the first example. Very powerful. How this can be useful is like if you have a really large model that you can run in our VM machine, with the GPU and high computing CPUs, and how many cores that you have actually can speed up the simulation time significantly. We have seen like 50 to 60% reduction in some of the models, especially a big, large 2D model. You just drop your IFB file and you just use this code to run the simulation. And I know this one is just gives you the percentage of completion of the runs. I know this is kind of, not very cool looking. So if you want to have some simulation bar, I can give you a very simple code here and we can try that as well. So I'm just going to copy this code here. It's just a very simple code that our team added this TQDM just to track the simulation, and then also we added some simulation progress bar. So I'm going to delete this RPT file just to show you. We'll regenerate this two files again, and it will be so fast you're not going to be able to see the if it's a huge model, then you're going to see this progress slowly moving right here. So, and it's created this RPD file and OUT file. So that's the exercise. We have a very powerful machine that you can leverage to run significant big simulations. So hopefully that helps, and we'll talk about the simulation results, how to view it, and also we have a lot of tools that we have developed. We will release it as open source for the community to kind of try it out. So that's the video. We'll see you guys on the next one.